Okay, let's begin. So, you guys had your shot at it. Let's see what. Let's see.
That's one way.
Let's see how the answers look.
So exciting.
It's not easy, is it?
No.
I'm up here. No one appreciates what I go through. Like, none of you guys appreciate it. Okay, so we're just gonna get through these examples. The length
Okay.
of r equals 2 minus 2 cosine theta on 0 to 2. Okay, so what's the formula here? What's the formula?
Length equals the integral from a to b of square root r squared plus dr d theta squared and then d theta.
Okay, so plugging that in, we have 0 to 2 pi. The radical is, we're going to square this, plus we're going to square its derivative. Derivative of that is, go.
2 sine theta.
2 sine theta, d theta, and we're going to square that. So what are we going to have here? It says 0 to 2 pi, that's the radical of 4 minus 8 cosine theta plus 4 cosine squared theta plus 4 sine squared theta d theta. So this is going to be 4, right? And so we have pretty much 8 minus 8 cosine theta. We can like factor out a radical 8 maybe. 0 to 2 pi, and we would be left over with what? 1 minus cosine theta, d theta. Okay, how do you guys integrate that?
Weierstrass?
Weierstrass.
Or not.
Yeah, what's the end game here? Weierstrass is going to put a rational function underneath the square root. How are you going to do with that?
We did.
Yeah?
There's an identity that you can
What
use,
identity did you use?
the half angle theorem.
Which is?
Sine squared theta is equal to 1/2 times 1 minus cosine 2 theta.
Right. Trick is make this a half angle, and we have that, and so we would have 2 sine squared theta over 2 is that 1 minus cosine theta. So this integral just becomes the radical of 8, 0 to 2 pi, and under the radical here I just have 2 sine squared theta over 2. Okay, so what's that going to be? That's going to be, well, radical 16 if I factor out the 2. And of course on this interval here, sine of theta over 2 is actually going to be positive. So technically it's an absolute value of the sine squared of sine theta over 2, but that's actually positive here. So it's just sine theta over 2. Technically they're absolute values, but they're not going to matter because it's actually positive on that interval. And so now we just integrate that, which is going to be, well, 2 radical 16 minus cosine theta over 2 between 0 and 2 pi. So you plug in 2 pi, it's minus 2 radical 16 cosine of pi, plus when you plug in 0 you get 2 radical 16. Cosine of pi is minus 1, so we just have 4 radical 16s. Radical 16 is actually just 4, so 16 is the answer. they're like, there's no way that's the answer. 16 was the answer, right? That's the situation when you're in a test, you get the answer, and you're like, that's not it, and you just erase it and then write something else. Yeah, because like, why would the answer be 16? That's so weird. Okay, that was problem 1. So the next problem 2, we have r is equal to sine theta. We want to find where are there horizontal tangent lines. So, first we need to find what? What do we need here? Yeah, but how do we know that there's a horizontal tangent line?
It's when d
y over dt equals 0.
Well, dy dx equals 0. But what is dy dx?
dy d theta over dx d theta.
Right, this is dy d theta over dx d theta.
You need dy d theta to equal 0 and dx d theta can't equal 0.
Right, and now and one thing you're going to notice when you're going to plug these guys in, well, I can just write it here. So, this means I want d theta of y, which is r sine theta. Our r is already a sine, so that's sine theta,
Yeah.
right? Because this is r sine theta. Divided by d theta of r cosine theta, so that's sine theta cosine theta. So that's your r cosine theta, that's your dx. So now you're going to have to, well, I can think of this as sine squared, so the derivative of that is going to be 2 sine theta cosine theta with the chain rule. And this is just going to be, well, I can think of this entire thing here as 1/2 sine 2 theta. So the derivative there is just going to be cosine of 2 theta, right? So that's pretty much going to be sine 2 theta over cosine 2 theta, which is tangent theta, tangent 2 theta. Is that what you guys got? Or did I mess up on the algebra here? This thing I thought of as sine squared theta. So the derivative, bring the 2 down, leave the inside, multiply by derivative of the inside, that gives us 2 sine theta cosine theta. This one with a trig identity, that's actually 1/2 times the sine of the double angle. So,
I don't think that's
Yeah.
huh?
Wait, do you have that in the paper too?
What are you talking about?
I don't know, we just didn't get that.
What answer did you get?
We used like the
Product rule?
Mm-hmm.
Yeah, and then we got like cosine squared.
Yeah, so you
sine
would
squared.
differentiate this, leave that, you would get cosine squared.
Yeah,
Minus plus, differentiate this, leave that, you get a minus sine squared.
Yeah, yeah, we got.
Well, that is cosine 2 theta by
Oh,
definition.
yeah.
Yeah, so you get it that way, so cosine 2 theta. So basically tangent theta is what the derivative is going to look like, which means I can use that to figure out the horizontal and vertical tangent lines. So for horizontal, this means that sine of 2 theta is going to be equal to 0 because that's the numerator. And this would mean that my 2 theta is going to be, well, it can be either 0, pi, 2 pi, 3 pi, 4 pi, etc. I did give a limit here, right? What was the limit? 0 to 2 pi?
Mm-hmm.
So my theta could be 0 or pi over 2
It was
or
0 to pi.
so those are all the values I need. I don't actually care about the rest of them. So 0, pi over 2, and pi will be where our these guys actually happen. So x would be r cosine theta. So that's going to be sine squared theta evaluated at theta equals 0, pi over 2, and pi. So the corresponding coordinates, the corresponding things there will be 0, or if I plug in pi over 2, I would get 1, or 0. My y would be are cosine theta. So that's going to be sine theta, cosine theta, evaluated at theta equals 0, pi over 2, and pi. So correspondingly, that will give me 0, 0, 0. So the coordinates are the origin and the point 1, 0, right? For horizontal tangent lines. For vertical, I need the denominator equal to 0. So this would mean my 2 theta is going to be cosine hits 0 at all odd multiples of pi over 2. So pi over 2, 3 pi over 2.
But I think you switched the x and y, because x was sine theta, cosine theta, and y was sine squared theta.
I did switch those. So
the coordinates would just flip.
that's x.
Yeah.
That's y.
So 0,
Yeah.
0, and 0.
So it's 0, 0, 0. 5 pi over 2, 7 pi over 2, etc. Now, which means your theta is going to be, well, pi over 4, or 3 pi over 4. 5 pi over 4 is already outside the range of 0 to pi, so only 2 candidates here, which means my y, which is sine squared theta, where theta is evaluated at pi over 4, and 3 pi over 4, that will give me coordinates. If I plug in pi over 4, sine will give me 1 over radical 2, so that's a half. If I plug in 3 pi over 4, all students take calculus, I'd still get a half. My x is equal to sine theta cosine theta, for theta equals pi over 4, 3 pi over 4. So plugging in pi over 4, they will each give me 1 over radical 2, so I would get a half. Plug in 3 pi over 4, because of all students take calculus, the sine will give me positive 1 over radical 2, while the cosine will give me negative 1 over radical 2, so that's minus a half. And so the coordinates I care about here would be minus a half, comma a half, and a half, comma a half. Those will give me the vertical tangent lines. And what is the slope? A second part here. What is the slope when theta equals pi over 3? Well, this just means I would plug in, I know that dy dx evaluated at theta equals pi over 3, that's just going to be the tangent of, it was 2 theta, so it's 2 pi over 3. What's the tangent of 2 pi over 3? You might not know that off the top of your head, but we can just, there's that. So, sine of pi over 3 is going to be radical 3 over 2, and the cosine is going to give us minus 1/2. So minus radical 3. That was the second part. Questions? You guys see what I mean? Yeah.
If the vertical tangent is in sine of pi over 4, rad 2 over 2.
Sine of pi over 4? Yes?
You put 1 over rad 2 for all of them.
Well, I mean, rad 2 over 2 is 1 over rad 2,
Oh, yeah.
right? I just wrote it as that
Oh, okay.
so that when I square it, it's not weird. Because then if I had rad 2 over 2, I would square that, I would get 2 over 4, which I would just reduce to a half anyway. So, yeah. So I thought of it this way instead of that way. Third problem. Sketches now, okay? So, area inside R equals 2 plus 2 cosine theta. It says include a sketch in your answer. So, I would immediately jump into this guy. The amplitude is 2. The baseline is 2. The amplitude is 2, so that goes up to 4 and down to 0. We have the period is going to be, so basically here, your A is 2, your B is 0, your C is 2, your K is 1, so your period is 2 pi, and your period over 4 is pi over 2. So this is pi over 2, pi, 3 pi over 2, 2 pi, and this should look like a cosine, which starts at the top, then goes to the middle, then goes to the bottom, then goes to the middle, then goes to the top. So that's the trig graph. What that means is, on the actual graph, on xy, I would have a circle of radius 2, circle of radius 4, and the angles will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so I would start at the angle 0 on the circle of radius pi over 4. At pi over 2, I will go to the circle of radius 2. At pi, I would go to the circle, well, I go to the origin. At 3 pi over 2, I jump back to the circle of radius 2. And then at 2 pi, I would end here. So it looks like a heart, and I want to find the area inside that heart. Notice that it is symmetric. So the area up here is going to be the same as the area down here. So I'll double the area of the top. But you don't have to. Alright, I'm just going to do that. So we know that the area is going to be 1/2 times the integral of r squared d theta. And in this situation, I am going to double that and just integrate from 0 to pi, because it's going to give me the same answer from pi to 2 pi. So this is just going to be the integral from 0 to pi of r squared 2 plus 2 cosine theta squared d theta. This is going to be 0 to pi of 4 plus 8 cosine theta plus 4 cosine squared theta d theta. So, actually, it would be nicer to do the 0 to 2 pi. Let's just do that. I mean, I'll get 0 anyway, but it's not going to be clear with what I want to do here. So let's just do that, because I want to take advantage of a trick. Once I have 0 to 2 pi, I can immediately say that's going to be 0 and not worry about it. That's the nice thing, right? Once you're integrating over a full period of sine or cosine, you always get 0. The negative part will cancel out the positive part. So I'm allowed to ignore that part, and I would have 1/2 0 to 2 pi of 4. How would I integrate the cosine squared?
1/2 1 plus cosine 2 theta.
Right. Well, times the 4, so it's going to be 2 times 1 plus cosine 2 theta. So, in other words, that's 1/2 times integral from 0 to 2 pi of 6 plus 2 cosine 2 theta d theta. And that is going to be 6 theta plus sine 2 theta between 0 and 2 pi. That's going to be 0, and that's going to be 1/2 of 6 times 2 pi. Is that what you guys got? Whoever did this problem?
Yeah.
Okay, was that one?
How do you cancel a cross?
Because it is what is your.
But if you there, say it this.
Before.
10 out of
area inside inner loop. So, this would be here, our A absolute value is 2, B is 0, K is 1, C is 1, and the period here is going to be 2 pi over K, so the period over 4 is going to be pi over 2. So, start at baseline 1, we're going to go up by 2 and down by 2. Split this into 4 sections here. That's going to be pi over 2, pi, 3 pi over 2, 2 pi. And I want to draw a negative sign, so that's going to be here. It's the bottom, it's the middle, it's the top, it's the middle. This is going to be here. I want you to notice that the area we care about is going to be the area corresponding to this part here. So we'll need to know what those guys are. So we're going to have 1 minus 2 sine theta equals 0. This means our sine theta equals 1/2. This means our theta is going to be equal to pi over 6 and 5 pi over 6. So this means, so this is in the xy plane. I want circles of radius 1 and 3. And I care about the angle pi over 6 and 5 pi over 6, as well as 0, pi over 2, pi, 3 pi over 2, and 2 pi. So at 0 we start on the circle of radius 1, we hit 0 at pi over 2, at pi over 6. At pi over 2 we're negative 1, which means we go in the opposite direction of pi over 2, so we go down here, we come back to 0 at 5 pi over 6, then we'll jump to the circle of radius 1 on pi. Then for 3 pi over 2 we'll jump to the circle of radius 3, and then back to the circle of radius 1. We care about this area right here. Notice that that area happened when we looped between pi over 6 and 5 pi over 6. So that's where my integral is going to be based. This means that the area is going to be 1/2 the integral from pi over 6 to 5 pi over 6 of r squared d theta. So that's going to be 1 minus 4 sine theta plus 4 sine squared theta d theta. And that would be 1 minus 4 sine theta plus 2 minus 2 cosine 2 theta. So this is going to be 1/2 times the 2 plus the 1 is going to be 3, so that's going to integrate to 3 theta. This will integrate to positive 4 cosine. This will integrate to minus sine 2 theta. And I'm going to plug in pi over 6 and 5 pi over 6. So here I would have 5 pi over 2 plus 4 cosine 5 pi over 6 minus sine of 5 pi over 3 minus pi over 2 minus 4 times cosine pi over 6 plus sine of pi over 3. So, 5 pi over 2 minus pi over 2, that would give us 2 pi. Cosine of 5 pi over 6 is what?
Negative root 3 over 2.
Negative radical 3 over 2. Sine of 5 pi over 3?
Root 3 over 2. No.
Yes, but what quadrant is 5 pi over 3 in?
Third quadrant.
Or the circle's like this, split into 3 parts. 1, 2, 3, 4, 5. We are in the 4th quadrant, so sine is negative. So that's going to become a positive radical 3 over 2 because of that negative. We already dealt with that guy. Cosine of pi over 6 is root 3 over 2. We have a negative root 3 over 2. And sine of pi over 3 is root 3 over 2. What do we have here?
3 pi minus 2 root 3 over 2. So minus root 3.
Yeah, so this is minus 2 radical 3 minus 2 radical 3 plus radical 3 by adding these together. So what do we have here? 1/2 times 2 pi minus 3 radical 3. Right? I don't know which group did that, if you got that answer.
Pretty much.
Yeah? Yeah, that's what it is, yeah. And I think we're out of time. We'll finish the other two. See what we did. Probably what I'll do is I'll put this into some extra credit somewhere. So there'll be an upside but no downside. I mean, if you didn't get anything right, it doesn't. You're just where you were. If you got stuff right, maybe I'll give you a few extra quiz points or something. We'll pick up next time.